Standard normal probability distribution. The most frequently used normal probability distribution is the standard normal distribution. This is a normal distribution with a mean equaling 0 and a standard deviation equaling 1. The graph of the standard normal distribution is shown opposite. So it has a mean of 0 and a standard deviation of 1. Note that it is usual practice to use z as the random variable for the standard normal distribution. So we use z as the random variable, not x. Although there are many normal distributions, tables of probability values for the standard normal distribution can be used to obtain probabilities for any normal probability distribution. This is why it is so important to learn how to calculate probabilities from the standard normal distribution tables. In the formulae and tables, page 36 and 37, there are tables of probabilities, which is the areas under the curve, of the form of the probability that z is less than or equal to z for values of z ranging from 0 to 3.09. And this graph or this curve can also be seen in the tables on page 36. So the standard normal distribution is a special case of the normal distribution. It is the distribution that occurs when a normal random variable has a mean of 0 and a standard deviation of 1. So a mean of 0 and a standard deviation of 1. The normal random variable, a standard normal distribution, is called a standard score or a z-score. So this is page 36 of our tables. We can see at the top right hand corner it says probabilities for the standard normal distribution. So here we can see our curve and we can see a massive table of z-scores. So z goes from 0.0 down to 1.0 in this column here, and from 0.00 across to 0.09 in this row. And then on the following page we have the normal distribution continued. Z goes from 1.1 down to 3.0 in this column, and across in the row it goes from 0.00 across to 0.09. So really 3.09 is the highest it goes up to. An extract from these tables, which give areas such as that shown previously, is given below. So here is just a small cutting out of the table. To find the probability that z is less than or equal to 1.6, we go to the line 0.1, which we can see here, and then across to 0.06, which we can see here. And we see where do they match up. And it ends up to be 0.5636. And we read off the value. Thus, the probability that z is less than or equal to 0.16 is equal to 0.5636. So we got these numbers because 0.1 plus 0.06 is 0.16. There are different kinds of area that we need to read off the tables. To do so, it is necessary to remember the following properties of the standard normal distribution. Property 1. The area under the entire curve is 1. So the area under the entire curve is 1. Property 2. The curve is symmetric about the vertical axis through z equals 0. So we have z is equal to 0 here. We have a mean of 0. These properties can now be used along with the tables to calculate many different kinds of probability connected with a standard normal distribution. We can calculate the probability that z is less than or equal to z directly from the tables if z is greater or equal to 0. And below we can see how to calculate other areas. So part 1, when we have a right tail with z greater than 0. For example, to find the probability that z is greater or equal to 1.75. This area can be found by subtracting the area to the left of 1.75 from 1. So if we have a look at our graph, we can see this is 0, and this is 3, so this point here would be 1.75. And we're interested where z is greater or equal to 1.75. So basically this blue shaded area to the right of 1.75. Whereas if it had said z is less than or equal to 1.75, we would have been interested in this area here. But it said greater or equal to, so we're interested in everything to the right of 1.75. So since we know that this entire area equals 1, to figure out what the blue section is, we can say 1 minus this area. So the probability that z is greater or equal to 1.75 is the same thing as 1 minus the probability that z is less than or equal to 1.75. And in our tables, we can see the probability that z is less than or equal to 1.75 is 0.9599. So we go to 1.7, and we go across, we go to 0.05, and we go down, and we get to 0.9599. So that's 1.75. And then 1 minus 0.9599 is 0.0401. So the probability that z is greater or equal to 1.75 is 0.0401. Part 2. If we have a right tail with z less than 0. For example, to find the probability that z is greater or equal to minus 1.25. So we can see this is minus 1.25 on our graph because this is 0. So this is minus 1.25. So this line here represents minus 1.25. And if we're interested where z is greater or equal to that, it's everything to the right of it. So this blue shaded section here. So by property 2, the area to the right of minus 1.25 is the same as the area to the left of 1.25. Thus, the probability that z is greater or equal to minus 1.25 is the exact same thing as the probability that z is less than or equal to positive 1.25. So 1.25 would be about here. So it's the exact same thing to get the area from here to the left as it is to get the area from here to the right. It works out to be the exact same area. So what we're going to do is go to 1.25 in our tables. So we go to 1.2 and go across, and 0.05 and go down, because 1.2 plus 0.05 is 1.25. We get to 0.8944. So the probability that z is greater or equal to minus 1.25 is 0.8944. Part 3. Left tail with z less than 0. For example, to find the probability that z is less than or equal to minus 1. So here we have minus 1, and we're interested in the probability that z is less than this. So everything to the left of minus 1. By property 2, the area to the left of minus 1 is the same as the area to the right of 1. So if this is 1, then the area to the right of that is the same thing as the area to the left of minus 1. Thus, the probability that z is less than or equal to 1 is the exact same thing as the probability of z greater than or equal to 1. And the probability that z is greater or equal to 1 is the same thing as 1 minus the probability that z is less than or equal to 1. So we know that the entire curve, the area underneath the entire curve is 1. And if this here is 1, and z less than or equal to 1 would be all of this area, then subtracting that from 1 would leave us with this area, which is the exact same thing as this. So now all we have to work out is the probability that z is less than or equal to 1. So we just go to 1.0 and go across, because 1.0 plus 0.00 is still just 1, so we get 0.8413. And then we have to subtract that from 1, leaving us with 0.1587. Part 4. The area between two values of z. This is the most awkward type of area or probability to calculate and covers a number of cases. We will look at the case where the lower z value is negative and the greater z value is positive. Cases where both z values are negative or both are positive are handled slightly differently, but use the techniques seen above. For example, find the probability that z is greater or equal to minus 1.5 but less than or equal to 0.75. So we can see this is minus 1.5 and this is 0.75. So we're interested that z is in between these, so this blue shaded area in between. This probability is shown as the shaded area in the diagram opposite. What we do is, step 1, read directly from the tables the area to the left of 0.75. So here we have 0.75 and we're interested in the total area to the left of it. So the probability that z is less than or equal to 0.75 is 0.7734. So we got this number from the tables. So we'll have a look at that in a second where we got that number from. Step 2, find the area to the left of minus 1.5 using the technique seen in case 3 above. So here's minus 1.5, so we want the area to the left of it. So the probability that z is less than or equal to minus 1.5 is the same thing as the probability that z is greater or equal to 1.5. And the probability that z is greater or equal to 1.5 is the same thing as 1 minus the probability that z is less than or equal to 1.5. And the probability that z is less than or equal to 1.5 is 0.9332. So we got that from the tables. And 1 minus that is 0.0668. So again, I'll show you in a second where I got those numbers from. On step 3, we subtract. So we're going to take this number, 0.7734, and subtract this number, 0.0668, and it will leave us with a shaded area in between. And we're left with 0.7066. So again, the probability that z is less than or equal to 0.75, we go to 0.7 and go across, go to 0.05 and go down, and we're left with 0.7734. And again, the probability that z is less than or equal to 1.5, so we go to 1.5 and go across, go to 0.00 and go down, and we get to 0.9332. So that's where that number came from.